Hello and welcome to Thursday's edition of Cracking the Cryptic on a truly horrible day here in the UK. I made a big mistake a few days ago in claiming that spring was arriving. It's most certainly departed the scene and it's fully wintry again now. But I'm going to try and cheer myself up late in the day by having a go at the new puzzle by the Dutch master Ard van de Wetering, surely the most popular Sudoku constructor on this planet. And I say that because Ard's puzzle, a Sudoku with only 4 given digits, that's been viewed 9 million times or more, and many of his other puzzles have been played and viewed over 1 million times. So Ard's puzzles are superbly popular, and this is called Where is the Eighth? I thought that said something different for a moment. Where is the eighth? And it's basically an arrow Sudoku with a knight's move constraint. So I'll go through the rules in a moment or two's time, and we can learn about what's going on in the puzzle together. But there are some things I wanted to talk to you about first. Oh yeah, firstly I have to make a apologise. It's really late today. I'm recording this at nearly 6 o'clock, so if Ard, please don't let this be one of your brutal ones, because let's say I spent an hour on this and then couldn't do it for some reason, then I'd be really under the cosh in terms of getting the 8:30 video up and running. So I don't know why I say that, but it just makes me nervous. Other things I wanted to say: thank you very much if you joined us last night for our Hexcells stream. Although Mark and I felt our performance was underwhelming in terms of certainly accuracy. There were 1 or 2 wine clicks. They were definitely my fault. And then there was one boo-boo where, I unhighlighted or highlighted a clue that I thought we'd dealt with, which we hadn't, and we then just couldn't see it. We couldn't see it for ages. It was so appalling. But you were all very kind to us, and thank you for that. And we will be returning to streaming. We're going to have a look at Hexcells Infinity next week. So watch this space for news on when exactly that will be. Now, the thing I was doing earlier on today was I was having a look at the feedback on Riffclown's Sudoku Hunt, which is our monthly reward over on Patreon, and it is stellar. Huge props to Riffclown for entertaining so many people. This is the Sudoku Gallery, which is of course the sort of flyer for it. Lots and lots of line Sudokus. And yeah, the feedback seems to be, most of it falls into 2 buckets. People loved the puzzles, and people loved the sort of difficulty, the way that the difficulty was achievable. You know, there weren't any absolute monsters in there, and it felt like the perfect curve. So well done to Riffclown. And if you are a patron, if you haven't had a look at that hunt, do have a look. You've got plenty of time. The competition closes on the 20th, but just make sure you take advantage of those puzzles because they're really special. And then I've got some birthdays to do as well. So let's start off by wishing Rachel a very happy birthday. And this is from your husband, Ruben. And I understand, Rachel, that your favourite cake is chocolate cake. So I think that means that Ruben is sorting you out. I don't think it was just written to tell me that. I think that must mean that you are getting chocolate cake today. I hope that is right. And I hope it is good chocolate cake, and many happy returns. And then Kat, this is a late birthday, but it's not my fault. This is from Charlie for yesterday, and Charlie said that he had sent an email, but we didn't get it. I did check, so I'm sorry about that. And I think Kat is short for Ketia, is that right? I know it's a Latvian name. I hope I'm saying that correctly. But I hear you were playing crazy golf on your birthday yesterday. Well, that sounds quite good. My views on crazy golf. Well, I think it's a fantastic form of golf. And frankly, normal golf should be divided up into normal golf until you get to the green. And then crazy golf can go and be a sport on its own, because putting shouldn't really be a part of golf. There, I've said it. But anyway, Kat, that's enough of me wibbling on about that. I hope you get chocolate cake today. Oh no, I hope you had it yesterday. I hope there's a bit left today. other than that, Audrey, you've turned 27 today, and I know this because your husband Theodore wrote to us with it, and this tickled me. Apparently, you do watch the Sudoku videos every night, and you ensured that on New Year's Eve, the video that you were watching that night, which I think was one of mine, you made it so that I said, "Let's get cracking," as the clock chimed midnight. That's completely mad and very, very cool. So you welcomed in the new year with cracking the cryptic. Everyone should do that. Audrey, many happy returns. And then finally, Pablo. Pablo, you've turned 23 today, and I know this because your girlfriend Tess wrote to us. And Tess says she's gifting you, I think, some sort of murder mystery puzzle book, which sounds quite good. And she wanted to let you know that she loves you very much. She's very proud of you. And you're getting chocolate cake, Pablo. So I think you're in for a good birthday, my friend. Right, and with all that said and done, let us see what the great Ard van de Wetering has in store for us. These are the rules of where is the 8th. We have got normal Sudoku rules apply. So we have to put the digits 1 to 9 once each in every row, in every column, and in every 3x3 box. Look, I get 5 given digits today. Fantastic. Digits along an arrow must sum to the digit in that arrow's circle. So let's look at this arrow. If this was 1, 3, 5, 1 plus 3 plus 5 equals 9, and we would write 9 into the circle. That's how arrows work. It's absolutely teeming down outside now. And then the only other rule is that cells separated by a single knight's move in chess cannot contain the same digit. So let's imagine the central cell of the grid was a 1. Now, if this was a chess knight, in a single bounce, it could go to any of those cells. So none of these cells could contain the digit 1, because obviously if we put a digit 1 in either of them, these are a chess knight's move apart, and that is a jolly bad thing, and you will get the puzzle wrong. Don't get the puzzle wrong. The way to play the puzzle is to click the link under the video as usual in the video description. Do have a go. Ard's puzzles are sensationally good. Now, I get to play. Let's get cracking. And we'll start off, I think, by noting that all the arrows are 3 cells long, I think. I think they are all 3 cells long. So there is some low-hanging fruit there, because we can immediately double-click them using Sven's remarkable software and fill in 6, 7, 8 and 9 into all of them. And that's because, of course, if the arrows are all 3 cells long and all the digits on the arrows have to be different, and that does seem to be the case, the arrows are all very symmetrical, actually. Yeah, but so this is the minimum we could put on an arrow would be 1, 2 and 3, wouldn't it? And 1 plus 2 plus 3 is 6. So every arrow circle is at least 6. Now this one can't be 8 because it sees 8 in its row. That one can't be 9 because it sees 9. This one actually can't be 6 either because it's got a 4 on it. So the minimum this arrow could add up to is 1 plus 2 plus 4 is 7. And whoa, the wicked wind is whistling through the windows. It's proper alliteration. Now, I can't see what else to do. It's going to be colouring, I think, this puzzle. I think there's going to be a way of us concluding that well, there are 2 things I'm wondering about here. Right, the symmetry is profound. I'm wondering about the title, frankly. Where is the 8th? Now, there are 7 arrows in this puzzle, and they are very, very symmetrically disposed, with a notable exception, which is that this box doesn't have an arrow, which the symmetry suggests it should have. Let me just show you that for a moment. So obviously those cells, you know, if we think about this arrow, and we imagine that the grid was on a spindle going through the very centre of the box, and we did a quarter turn of the grid, this arrow would just become this arrow, wouldn't it? And then if we turned it again a quarter turn, it would become this arrow. So these are all very symmetrical. And that very nearly applies to these arrows as well. Again, if we spindled the grid. Yeah, they do. So I think what the title is saying is sort of saying, why isn't there an arrow in this box? And that I presume is because it wouldn't work. It makes me think that there is a well, it makes me think we're looking at exploded Fistomerfell, frankly, because we've got these 2x2 boxes. And here is an axiom to remember. If you find that 2x2 boxes, especially in boxes 1, 3, 7 and 9 of a Sudoku, are in any way constrained or they seem to be interesting, definitely think Fistomerfell, because this could be the extended Fistomerfell thing, which I can never remember which cells actually incorporates. I think I'm going to do this first. Let me just show you the other thought I was going to have. Was I could see this digit, for example. Oh, there's Knight's move as well, actually. Yeah, so this cell, where does that go in this box? Well, it can't go in its own row, and it can't go on its own arrow, can it? Imagine that cell, whatever's in this cell, went on the arrow. Let's imagine it was a 6. So 6 would be equal to 6 plus 2 other digits, and these digits would both have to be 0, and that's just silly. So that's not going to work, and that means this digit is actually in one of those 2 squares, which means in turn it's in one of these 3 squares. Yeah, you see, I don't know. It could be this, because I bet you there's a way of, you know, proving, for example, that all 4 of these have to be different. I'm not sure. Let's first, I think firstly, I'm just going to check what Fistomerfell does to this box, because that does seem to be, well, it seems to be in tune with the title, and it's also, well, frankly, it's screaming out at us a bit. Now, I can never remember how to do the exploded Fistomerfell thing. I think what we have to do is highlight the perimeter. So it's something like this. Now, yeah, but the corners are going to count. Okay, let's do this slowly, actually, because the corners are going to count twice. So if you haven't seen... Well, let's just talk about Fistomerfell quickly, very quickly. I won't prove it, but there is a theorem in Sudoku that tells you that those 16 digits that surround the central 3x3 box of a Sudoku, so these green cells here, these are the exact same digits that you get as the 16 cells in the 2x2s in the corner. And you can try that on any Sudoku, and it will be proved to be true. But there is a variant of this. The proof of that can be applied into lots of different sets in Sudoku, and the one I'm thinking might be relevant because it shifts those 2x2s which were in the corners into these positions, which are the ones that look interesting to me. That proof, I think, relies on looking at the perimeter. So let's look at this row. Now, can we describe the contents of this row? And the answer is yes. We know, because of the rules of Sudoku, that these green digits are the digits 1 to 9 once each. Now, we haven't got a clue about how, well, I don't have a clue anyway, about how the digits are arranged within this strip. But I do know that collectively that is one set of the digits 1 to 9. So what about that? What's that? Well, that's clearly another set of the digits 1 to 9. So far, green contains 2 sets of the digits 1 to 9. Well, what would happen if we added the whole of column 1? That would be a third set of the digits 1 to 9, provided, of course, we included this cell and this cell again, because in column 1, the whole of column 1 includes this cell and this cell again. So in order to claim that that green constituted 3 sets of the digits 1 to 9, I've got to make sure that these corner cells here are double counted. So whatever digit happened to be in the corner would be in green, the green set twice. And I can do the same in column 9. So if I highlight the whole of that column to claim that I've got that green was 4 sets of the digits 1 to 9, that would be true if these corner digits were in twice, because they're definitely in this corner, for example, is definitely in row 1, and it's definitely separately in column 9, isn't it? So these cells altogether are 4 sets of the digits 1 to 9, providing we count the corners twice. Now, if we highlight this whole box, this whole box, this whole box, and this whole box in blue. Now, what's the blue set? So we understand what the green set is. What could we describe the blue set as being? Well, obviously box 1 is 1 set of the digits 1 to 9. It's the whole Sudoku box. Same with box 3, same with box 7, same with box 9. So blue altogether is 4 sets of the digits 1 to 9. And that's the same as green. So the key to understanding what that can lead to, what we can do with that, is to look at that cell, for example, and say, well, what would happen if we removed this from both the green and the blue sets? Let's take it out of both. That cell's contents have now disappeared. What can we now say about the green and the blue set? And you may say, well, we can't say very much. And in a way, yeah, it does become more complicated, because previously we knew that green and blue had 4 sets of the digits 1 to 9 in. So we knew there were 4-digit 1s, 4-digit 2s, 4-digit 3s, all the way through to 4-digit 9s. Well, now, because we haven't got a clue what this digit will be, this cell's contents, we don't know, do we? So we can't now describe the 35 cells we've got left as, 4 of everything but only 3 8s or something, because we don't know. But we do know that whatever is in this cell, we've removed it from green and from blue. And we know that before we did that removal, green and blue were the same. So what's the comparison now between green and blue, having removed this cell from both the green and the blue set? Well, they still must be the same, because they were the same before we took the same thing out of both sets. And we can keep doing this. We can take the same thing out of all these sets, out of any cell that's got sort of a bichromatic appearance. We can just remove from both sets, and that will preserve the relationship between green and blue. Now, the corners are more complicated, because remember, the corners were twice in the green set and they're only once in the blue set. So I can remove the corner cell once from the blue and once from the green, which will leave 1 of these digits in green. And we'll get this situation. Now, we should have, and we do, we have 16 cells left that are coloured green. We have 16 cells that are coloured blue. And these are the same digits. We don't know what those digits are yet, but they're the same. Yeah, I can see exactly where this is going now. This is just beautiful. This is classic art. It's classic art because, in fact, it's weird art as well. So what art is actually... let's do this stage by stage, because I can see where this is going, and I'm sort of a bit surprised by it, but it's quite beautiful. It's quite beautiful. So we know that green and blue are the same digits overall. We don't know what the digits are yet. So let's ask a question. What is the sum of green compared to the sum of blue? Well, obviously, because green and blue have the same digits, if you add up all the green digits and you add up all the blue digits, they're going to give the same number, aren't they? But remember the rules of arrow Sudoku. These 3 digits here on an arrow add up to the same as the digit in the green circle. So if I was to remove these 3 cells from the blue set and this cell from the green set, then the sum of green and the sum of blue should be preserved. Although the number of digits in green and blue will have changed, the sum of each set will be the same number. So let's do that. Let's take this out of blue and this out of green. Let's do that for that arrow. Let's take this out of blue and these out of green. Let's take these out of blue and this out of green. And we can keep cancelling these arrows. It's quite gorgeous. Look, they're all going to cancel, except for one. Well, except for this. So we've now basically proved that this... So what we're left with in the blue set are these 3 digits, and what we're left with in green is this digit, and we know they have the same sum. Well, that's interesting, because that's the missing arrow. So this is the point. Must be the break into the puzzle. Where is the 8th arrow? Well, actually, it was always there. And that's the bit that I'm struggling with a bit, because, in fact, look, let's use Sven's software. We can probably... no, it's a bit dark, isn't it? Let's go for that one. Oop. That's probably about as good as we'll do. There we go. So we know that there is an invisible arrow in box 9 that mimics all of the others. And that exists in the puzzle. Although it's not shown, it just exists as a feature of a puzzle that has this arrangement of circles. So any puzzle that has that arrangement of circles has a hidden arrow that is symmetrical in the other corner. That is gorgeous, isn't it? That's a bit head-wrecking. Right, but that's presumably going to do something. Well, the first thing it does is because we've worked out that this digit is the sum of 3 different numbers, that digit is at least 6 again. Just so in effect it's become the 8th circle. Oh dear, hang on. I'm sure this is the break-in. I've just got to work out why it matters. So you can't put 6 on the blue cells anymore, because this 6 here sees that cell by the knight's move. So these digits are very low digits. You can never put 7, 8 or 9 on a 3-cell arrow, because, well, imagine we tried to make this a 7. Once we'd added at least a 1 and a 2 to it, this circle would be 10 or higher, and that's not valid. So these digits, because they can't include 6 either, are low. These are not 3. That digit is also low, isn't it? Because that's on an arrow and it's not 3 or 6 and can't be 7, 8 or 9. So that is... No, that's not a quintuple. It's the bones of a sextuplet. Oh dear, this is... I'm so sorry. I was absolutely convinced that this was what we were meant to do. Once I saw this emerging, I was convinced this was right. I might well have just wasted everyone's time there, I'm afraid. I don't understand. It was still beautiful. I mean, I think that's still interesting, even if it's not relevant to solving the puzzle. Oh dear. It feels like it must be this row, doesn't it? Because that is a real restrict. I could not have learnt that these digits were so low, if I didn't have that this relationship between blue and green. What am I missing there? Oh, that digit is in one of those 2 squares. So it is down there. It could be green, but it doesn't have to be green. Okay, that one doesn't have to be 6. Well, when I say it doesn't have to be, it can't be 6. Oh no. Oh dear. Right. Okay, sorry. This didn't need... This didn't need the exploded Fistemafeld proof. That digit, where is it in this box? Right, let's start. This is not 6, Because if it's 6, this has to be a 1, 2, 3 triple, which it cannot be. So that is not 6. So it's 7, 8 or 9. So where does it go in this box? It can't go on its own arrow. It can't go in its own row. And it's not equal to 6 or 3. So that digit goes there just by force of nature. So it's not 8, actually. So that's not 8. So it's 7 or 9. And it's 7. It's 7. Because how do we make 9? That if this was 9, the 3 cells that would be adding up to 9, there are only 3 ways of making 9 in 3 different digits. 1, 2, 6, that's ruled out. 1, 3, 5, that's ruled out. And 2, 3, 4, that's ruled out. So this cannot be 9, and it is 7. But the slightly the slightly awful thing about that is that did not need, I didn't need this to know this. That was just there, wasn't it? This can't be 7 by the night's move. That can't be 7 at all now, but because of the that Fairweather Friend Sudoku. So okay, and a 7 arrow has to be 1, 2, 4. So these squares have to be 5, 8, 9. Whoops. And that's very distracting. There's a 4 on this arrow now. Oh, well, okay, that's something. That is something I have learned. Oh, no, that gets rid of 6 in the corner. Actually, this corner digit is higher than we now. Okay, all right, so this is doing something at this point. Because 4... no, this is gorgeous. No, this is gorgeous. Right. Right, this is beautiful. This is an 8. This is an 8 circle by maths. Let me show you. This is absolutely beautiful. Right, look, this is a 7 or an 8 arrow. So what digits do we know are on this arrow? And the answer is I don't quite know, but I know it's got 1 on it. It's either 1, 2, 4 or it's 1, 3, 4. So in fact, let's put it, those digits are definitely from 1, 2 and 3. But look at this triple and this triple. If we compare them and think about where the common digits between... Oh, in fact, there's another way of looking at this. Imagine this had been a 7 arrow, and this had been 1, 2, 4, and this was 1, 2, 4. Well, then this would have been 1, 2, 4 in box 9, our invisible arrow, and that would have been a 7 in the corner, and that would have clashed. So there's no way this could be a 7 arrow. I mean, the way I was getting to that was more complicated. I was seeing this as having 1 and 4, and this is having 1 and 4, and therefore this arrow having 1 and 4, and then I could see it couldn't be a 9 arrow because that would require double 4 here, and it couldn't obviously be a 6 arrow, then I'd have eliminated 7 in a similar way. But this has to be 8, and therefore this, which we know has got 4 on it, is now definitely, well, it's definitely 1, 3, 4, and the 3 must go there. So this is a 1, 4 pair now. Let's put that in. And this is a... Well, we know this can't be 1, 2, 4, don't we? That's basically what we're saying here. This can't be 1, 2, 4, so that must be 8. This must be a 1, 3 pair. So this arrow is the same as this arrow, which is a bit strange. And the result of that, well, that 3 is seeing that by knight's move now, so that's got to be a 1, that's got to be a 3. That 1 is seeing this by knight's move, so that's got to be a 4, that's got to be a 1. I've got 1, 3 pairs in columns 8 and 9. Now, I can't quite knight's move that, I don't think. 4, where is 4 in column 8? By Sudoku it's in one of these 2 squares, but by knight's move Sudoku it's not in this one. So it's got to be at the top. It's sort of a Tigger bounce away from this 4 here. So there's now no 4 on this arrow, so this can't be a 7 arrow. Could it be 6? 1, 3, this would be a 2. That would be a 2 over here in one of these 2. 2 in one of those. Oh, in fact, look. because this is a 1, 2, 4 triple, where is 2 in this box? And the answer is in one of those two squares. This is not 8 in the corner by Sudoku. So 8 is in one of two places in box 7. This square is not 1 or 4, so this square is 2 or 5. And and I'm stuck. Oh no, hang on. 8 can't go here because of the knight's move. So 8 is in a, well, a non-continuous domino in column 7. 5, 8, 9. So in this box we've got 2, 5, 6 and 9 to place. So that square is just 2 or 6. 5, 6, 9. 9 is in one of those two positions, I think, because of the given 9. Six. Yeah, the 6 can't go here because of the knight's move constraint, and it can't go there by Sudoku. So 6 is in one of two positions. Okay, that doesn't actually seem to be doing it, does it? This arrow can't have 3 on it. That's good. This arrow can't have 3 on it. So it can't be a 6 arrow. That would need 1, 2 and 3. So that means that... yeah, I see. Right, this can't be a 5. Because a 5 can't go on a 7 arrow full stop. And if it was a 9 arrow, it would be a 1, 3 pair beneath it. And we just said there's no 3 on this arrow. So this cannot be a 5. This is a 2. And that means that's a 2. And we've got 6. Oh no, this isn't 6. I didn't see that. Look, there's a 6 looking at it. It's Sudoku. I mean, I can't believe I'm being asked to do Sudoku in this Sudoku puzzle. Right, so now I've got 5 or 9 here. And, well, if this was a 7 arrow, that's a 1, 4 pair. And if this is a 9 arrow, this hasn't got 3 on it, has it? So it is going to be a 6, 1 pair. So there's definitely a 1 in one of these two cells. And that's not a 2 by knight's move. That's not a 4 by knight's move. In fact, okay, in this row, I've not put 1, 4 and 6 in, and I know there's a 1 here, so this is a 4 or a 6 just by Sudoku. So this arrow now, this arrow is either adding up to 8 or 9. I don't know what to do with that. What are the options for these squares? These squares are 5, 6 and 9. Yes. Okay, sorry. I can just do that. That's got to be a 6 by Sudoku. 6, we've already looked at this. I just didn't notice I got the 2. And I could have used my pencil marks to get me that. So there we go. We get a 6 here, which means 6 is now in one of these squares, not there by knight's move. Right, there's a 6, 8 pair in this box. So these squares are 2, 5 and 7, I think, by Sudoku. And that's lovely. Look at this. This 7 sees that one and that one. So we get 7 here. A 2, 5 pair. The 2, 5 is resolved. That's 5. That's 2. So that's 2 by Sudoku. I've now got a 2 on this arrow. So it cannot be... well, it's got to have 1 or 3 or both on it. It can't be 8. It's looking at 8. So it's either a 1, 3 pair or... it can't be 2, 3, 4. Yeah, I think this has got to be a 6 arrow now. I'm not 100% sure, but it's got 2 on it. So how can you make these 2 squares add up to 7? If you can't use 1, 6, 2, 5 or 3, 4, you can't do it. So that's got to be a 6. This is a 1, 3 pair. This top digit is something 5 or 9, looking at the column, these 2 digits. And that being a 6 knocks 6 out of this one. These squares are 5, 7 and 9. Where does the 7 go in this box? That 7 sees that square. So it's got to go there. That's got to be a 5 or a 9. I've got a sort of weirdly symmetrical pattern of 5s and 9s. This 7 is looking at that square. So this has become 6 or 9. And I was about to say that can't be 1, 2, 3. That's not true. Although... No, maybe it can be. If it was 9, then let's think about that. If it was 9, it wouldn't have 4 on its arrow. So it's definitely got 1 on its arrow. Definitely, because it's either a 9, which is going to be 1, 3, 5, or it's, in fact, it's got 3 on the arrow. I've just realised that as well, because it hasn't got 4 or 6 on it. So the only 9 version that works here is 1, 3, 5. So this is either 1, 2, 3, or it's 1, 3, 5. And that's never 3, ever, by Sudoku. That's never 2 by Sudoku. Bother. Oh, that's not 8 by Sudoku. This has definitely got 1 and 3 on it. So if that, whatever that is in one of these, and therefore in one of these, probably on the arrow, whatever this has got on it is in one of these, and is in one of those 2. 8, look, where is 8 in the top row? It can't be here because of the knight's move, so 8 is in one of 2 places. 7 is also in this panoply of digits because 7 has to be in one of those 3 squares, not that one by Sudoku. So 7 is in a domino, and therefore 7 also takes a trip into the start of row 1. There was no value, was there? I just had another thought. I think I can get rid of the colouring just to have my thought play out. Let's get rid of the colouring. I was just wondering with the 2x2s, it's not about keeping track of. Let's just restate the exploded Fistamafel proof, and just let me have a quick look at that. Actually, I don't like the yellow. I'm going to use blue. Because what I was just thinking is, can I map these high digits into the green or vice versa? Like I now know the 6 and 8 have to appear in green because they appear in blue. So 6 has to... Yeah, that's it. That's done it. Yeah, that's oh, and I think that's probably been available for ages. But I only just had that thought. But oh no, it's wrong. I'm wrong as well. Oh, I nearly made a boo boo. Oh bother. Right. Okay. Well, that makes me feel better that maybe I haven't missed an easy point. What I was going to say is because I know that there is a blue 6. Can't I just place it in green? You can see none of these can be a green 6. But I was forgetting, of course, you could have a green 6 on an arrow, because 6 can go on an arrow if it's accompanied with 1 and 2 to give you a 9, and you can still make the circle work. Bother. Although, it's quite tricky to do that. I mean, like, if there was a 6 on here, this would be a 9, and then you need a 9 in green, which would have to go there. But that's probably okay. Okay, all right. Forget that. That's although there's a 6 here, that's a 9. Yeah, no, I can't disprove that. Sorry, that I think that's a much more complicated thought than I should be thinking about. Because we were doing okay, weren't we, with the knight's move, jiggery pokery. Let's try and return to that. What could we say? Do we know anything of any use? Where is 2 in this box? That must be an interesting question. No, nearly. Can't go there because of the knight's move, so I think it's got 3 possible places. What's the digit? 3. Where's 3 in row 9? It's got to be in one of those 2 cells. Golly. Sorry about this. I am not sure. I was about to say this digit might be worth a thought, because there is a theorem, Potato Head's theorem, about knight's move Sudokus, which is says something like, in a knight's move Sudoku, you can only have a maximum of 1 digit that is not in the Fistamafel ring. So you can't miss 2 digits out of that ring, because any digit that is not in the ring actually has to go in the middle of the grid. But I wasn't going to use that theorem. What I was simply going to observe is that this square by knight's move, obviously it sees all of these squares, so it cannot be duplicated in any of those squares. So it's under quite a lot of pressure naturally. But then I started to think about it, and actually, the 6s are duplicated, so I'm not sure it is under that much pressure. The 7 and the 3 are duplicated there. So I think that's got a lot of options. Oh, I've come to an absolute standstill here. How long have I had? 42 minutes. Okay, well that's still okay if I can get through the puzzle as far as getting the video up. Oh, please, Ard, what have you done with the puzzle? Why can't I see how to do it? Why can't I see how to do it? Could we do... I can get 7. Right. Okay, I can get 7 in this box. Because where is 7 in this box? There's a 7 there, there's a 7 there. This 7, this naughty little 7, can jump by knight's move into that and create an H in the middle box. So the 7 in the middle box is vertical and is therefore ruling out that one. So that becomes a 7. And that's going to mean absolutely nothing. Well, although that does restrict this digit in a way that it wasn't restricted before. That digit there, where does that go in this box? That's quite an interesting question, because obviously it can't repeat in its row, it can't repeat on its own arrow, it's definitely not equal to 7, and by knight's move it can't go into this square, so that square is orange. There is still the option of a 9 here, so we don't know that this is 6, it still could be 9. Because 9 could go into that square. Okay. Oh, botheration, I don't know. What could it be then? I don't know. I don't feel like I'm even... I don't feel I'm seeing anything remotely intelligent here. I know this has got 1 and 3 on it. I don't know whether it's got 2 on it or not. No, it just isn't seeing anything clever. No, that's not a very clever thought. I'm not even going to voice that thought that I just had there. It's so bad. Wow, I don't know. What on earth am I missing here? I mean, that maybe. Can we go back to colouring then? Is that what I've got to do? That was my first thought, almost. 7, 9. I mean, cells like that are restricted a little bit. The 6 and the 8 here, that's classic Knight's Move trick. You can't put 6 or 8 now into either of those squares. Because imagine you did try and put 8 here. It would rule 8 out of both of these squares because of the Knight's Move constraint. So that digit there has to be quite a low digit. Although it might be able to be 5. Because it can't be 4. It can't be 6, 7, 8 or 9. So it's 1, 2, 3 or 5. Looks like there's something maybe trying to go on in column 6. Wow, I don't know. I'm really struggling here. I'm sorry if this is obvious. I do not think it's obvious at all. What about that one then? Should we try the same trick on that cell? That could be... Oh, it's horrible. I think it could be loads of things. No, it could be... I'm not trying it on that. I refuse. That cell? I mean, that cell sees 9, 7, 5, but that one doesn't... Oh, I suppose it sees 6. Oh, yeah, alright, let's have a look at this one, because that one does see lots of low digits. It sees 2, 3 and 4 by the mechanism of Knight's Move. So can that be 1? I think so. It can't be 2, 3, 4. Or 5, actually. Or 6, or 7. Oh, look, this square. Ah! I think it can be 8. It can't be 9. So that square is really, really restricted. That might be important. He says, desperately trying to work out why that might be in some way. It's not 3s, is it? No. Okay. I'm going to look at that square as well, because that square sees the whole of the 5, 8, 9 triple beneath it. So that square, yeah, that is interesting as well. Okay, so that can't be 1. It can't be 2 because of this 2, or that 2. It can't be 3. Can it be 4? No, it actually can't. There's a 4 looking at it. 5, no. I hope this can be something. 6, maybe. 7, apparently, using my pencil marks. It can't be 8 or 9. That square is 6 or 7 only. Isn't that crazy? Okay. That's really strange. But I'm not sure it's actually that useful. Is there something I'm missing here? Or some things I'm missing here? 8. Where's 8 in the middle box? It's not here, is it? It's not there by medium of the Knight's Move. It's not here because of the 6, 8 pair. Oh, bother. Look, it's in one of those 2 squares. That might be important. Oh, it's not in the middle. Oh, it's obvious. Oh, I mean, I say it's obvious. Is it that obvious? Maybe it is. Maybe it is. Yeah, sorry. Where is 8 in box 5? It can't go there because it would rule both greens from being 6 or 8. So 8 is placed. That's going to do Is it going to do work? Yes, it's going to do work. Now this is an 8. Is it doing more work than that? I don't know, actually. I sort of thought it would be, but maybe I'm wrong. Oh, I don't know. That's so peculiar. Okay, all right. That apparently that didn't work. Let's try maybe 8 over here. No, 8 can't go there because of the knight's move. 8 actually can't be on an arrow, 3-cell arrow. So 8 is a bit more restricted. 8 is in one of 3 cells, and maybe we can do better than that. Or maybe we can't. Ah, where's 4 in box 2? That 4's knocking out this square, so 4 is vertical. Is that good? Oh, it nearly is. So 4 is in one of those 3 squares, I think. But again, I mean, it's quite good, but it's not enough, I don't think. Oh, no, it is enough. That 4 is doing work down here. Look, that's not a 4. So this is a 4, which means that's a 4. That's good. Okay, that's definitely better. So 4 is in one of these 3 squares in row 5. Oh, hang on. Oh, okay, here's an interesting point. Where's orange now in the middle box? Orange is a 6 or a 9, so it's not in its own column. It's not in the middle square. It's not equal to 8 or 4. So orange is in one of those squares. Oh, that's beautiful. That's fantastic. Because if orange is in one of those squares, how could orange ever be 9? This square can't be 9 for some reason. Oh, I see. If it's 9, it knocks 9 out of box 8. And that can't be a 9 by plain old Sudoku. So orange is 6. Ah, here we go. Orange is 6. So now this is a 1, 2, 3 triple. That's not able to be 2 by Sudoku. Well, by knight's move. That's not able to be 3. 6 is orange. So let's fully award 6 its colour. Okay, and what we're saying is that 6 is in one of those squares, which is where 7 is. So this is a 6-7 pair. So now 6 in row 5 is not in any of those cells. 6 can't be here by knight's move. Of course it can't be there by Sudoku, but never mind about that. So that's got to be a 6 in one of these 2 squares. Oh, that's great. That's great as well. Look at this square. That can't be 6, because if that's 6, this has to be a 1, 2, 6 arrow, and that square can't be 1 or 2. That won't work. So the 6 is not here. So 6 is here. And that means that's 6 apparently. Okay, that's good. So now I've got a 1, 4 arrow down here, which has got a 2 on it. So I put 7 in the corner. Nobody puts 7 in the corner, apart from me. There we go. We get 7 in the corner. We got 3, 5, and 9 down here by Sudoku. And this 4 stops that being a 4, so that's 1, that's 4, that's 4. I've got a 4 and an arrow now. And can we do something with this 1, perhaps? Well, 4 is in one of those 3 squares. Let's put that in. That's not 4. So 4 is on this arrow as well. So if this was an 8, this would be a 1, 3 pair. And that would be in one order. There would have to be a 1 here, and there would have to be a 3 here. If this is a 9, it's got a 4 on the arrow, so it has to be 2, 3, 4. And that can't be 2, so that would be 2, and that would be, this is always 3. is what we've just learnt. That was an incorrect removal of a pencil mark. So that's a 3. Where's 3 in the middle box? There or there? Can we do better than that? Apparently not. Let's get rid of the 7 in the corner here. Ah, look at this column. I've got a 1-2 pair that I hadn't seen. So I need 4s, 5s and 9s to complete the column. So what's that? That's not 4. It's 5 or 9. I'm not sure whether we can... Can we eliminate one more thing from there? I don't know. But these squares are from 4, 5 and 9 as well. I don't believe it. Okay, so this square is a 5 or a 9. Ah, now I've got a 5-9 pair in this column, so that's not 5. So this is 1, 2 or 3. What do we need in this row? Is it 1, 5 and 9, isn't it? 1, 5 and 9. Now can we get rid of anything from these? Can I get rid of 1 from here? Or I can't, you know. Well, at least I don't think I can. This is not easy. This is really, really not easy. At least for me. I mean, there could well be a very simple thing that I'm missing, but it's proving recalcitrant. Let's try. Do I know somehow what this arrow or this arrow is? Oh, golly, where does that digit go in this box? That almost looks like deliberate setting. I mean, it wouldn't surprise me, but where does it go? It can't go in its column. It can't go in column 1. It's not by knight's move there, and it can't go there because it sees that naughty little 8 by knight's move, and it sees the given 9. So these 2 digits rule it out of here. So that is a red digit. That is an 8 or a 9. And therefore, I've seen one thing that... Actually, I'm going to take that, I think. I've seen one thing that does. I think I might be able to do something here. But I've seen something easy, so I'm going to do that. This square is not 7 anymore. Well, it's not been at 7 ever since this was a 7. But now, where's 7 in this box? It's got to be in one of these 2 squares. And that means that square is a 6, which means that square is a 6. It means that square is an 8. That square is a 7. That's got to do something. I mean, how many 6s have I got now? I feel like have we got all of them? Well, maybe we've got all of them, so it's not going to do anything. Yeah, look, we've got that one as well. Let's get rid of the colouring for this square. We've got all the 6s. So what else did we learn from that? We learnt about 7s a little bit. We've got an X-wing of 7s left. Oh, we got rid of 8 from this square. Is that useful? Gosh, I don't know. I don't know. Maybe I've got to go back and think about this digit then. That can't be 8 or 9. Because again, the 8 and the 9 see that square. So this digit, which can't go here, is either there or there. And then either there or there. But it could still be here if this is 9. Good grief. Okay, so we're still not home and hosed here at all. Maybe I've got to do 1, 2, 3, 4. So 5s, 7s, 8s and 9s into here. It's not quite good enough. This is absolutely bizarre. No, I'm sorry, I'm corpsing, aren't I? I haven't got I don't know what to do. 2, 8 and 9. That's 2 or 9. I mean, it could well be that it's a 9. Hang on. That square is 2, 8 or 9, and it's not 8 by knight's move. So it's 2 or 9. Now, can it really be? Can't we rule something out of that cell? I don't know. That digit is also 2, 8 or 9, and apparently can be all of the things. Good lord. Okay, alright, so I don't know how to do that. I do know one of these is a 3. Have we used all the low-hanging fruit we could possibly use? Do we know? I mean, the weird thing was, when we got this 6, 7 thing resolved, it really didn't do very much for us. It's probably going to be like that there's, you know, it's going to be like that digit's looming in and seeing something by knight's move that I'm just not spotting. I am well aware that but that is a hazard of the knight's move puzzle. It's definitely a hazard of the knight's move puzzle when you're trying to do a quick solve of anything. Right, let's try and work out. Is there a reason for instance, that this arrow is restricted? We know it's got 4 on it. So is there a reason this can't be a 2, 3, 4 arrow? It's quite hard for it to be a 2, 3, 4 arrow. The 2 on it would have to go here. Is that broken for some reason? Don't think so. That would have to be the 4. This would have to be the 3. That doesn't look broken. Alright, can we put a 1 on it? If we have to put a 1 on this arrow, it has to go there. Is that broken for some reason? Yeah, that's broken. Gosh, that's difficult to see. Okay, so the question is, there must be an easier way of seeing this, but I don't know what it is. Can we put 1 on this arrow? Now, the only place a 1 could go on this arrow is into this square, and you can then see you can't put 1 on this arrow because you can't then put a 1 at all in row 5 of the grid. So this is not a 1, and therefore there's no 1 on the arrow, so it must be a 2, 3, 4 arrow. And we can now see that's not 2, that's not 2, so this is 2. And that means that that's not, it means, well, there we go. So now we've got an 8, 9 pair. This is now definitely a 2. That's not a 2. There's now a 2 down here. This is a 1. There's now a 2 up there. And can we do better? I think we can do 2 in this box, probably. Yeah, we can. That's just Sudoku. So 2, 4, 3. This is now a 9. So that's a 9. Now, that's a 5 in the middle of the grid. This is going to finish the puzzle. Now, that's got to be where the 9 goes in this box, which means this is a 1. Jeepers creepers. What a clever thing this is. So that's 8. 9 comes out of all these squares, so we get left with a 3, 5 pair at the bottom. So that's 9, that's 5. The funny pattern at the top is going to unwind itself. That's probably quite useful for reasons I haven't detected yet. This is a 5, 7 pair. The 5 is going to force that to resolve that way. That becomes a 7 by Sudoku. That does the 5 and the 3 at the bottom of the grid. That square there should be an 8. That's an 8 now, so that's a 9. Oh, we knew that by maths, actually. I could have done that before, just wasn't keeping track of it. The 4 in the middle, or in this box, goes here. Get left with a 5, 9 pair, which is resolved by the central cell. 5, 9. I hope we don't get a deadly pattern. That's looking a bit deadly-ish. There'll be a knight's move that'll somehow resolve what looks like a very deadly looking pattern. Probably. He says, desperately trying to spot where the knight's move happened. Oh, it's there. It is there. That 3 sees that square. So that's 1. That's 3. That's 3. That's 1. This 1 then pokes in. Well, we could use the 3 as well. And over here we need a 1 and we need a 5. And there we go. What a puzzle that is. Let's get rid of the colouring for the 9s. Is that right? Yes. One person has solved it, so whoever put this in the software for me, thank you very much. That is a brilliant, brilliant puzzle. Where is the 8th arrow? Well, it was there, Ard. It was there, hidden in plain sight all along. Isn't that brilliant? It was slightly chewier at the back end than I was expecting, especially after we got the breakthrough. Well, although I don't know. I probably missed something really obvious there, but that is a feature of Night's Move puzzles. You can come a cropper on them, because if you don't spot some implication of a digit that you don't normally scan for, poking into a cell and removing an option, it can get they can be impossible, or they can feel impossible anyway. But what my favourite part of this puzzle is the fact that is the title, actually. Where is the 8th? Because it's the title that makes you think about, where is that 8th arrow? Oh, well, it seems to want to be there. Well, what does that mean? Oh, and then you do the Fistamafel thing, and it is there. You just couldn't see it. Let me know in the comments how you got on. I enjoy the comments, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.